All right, so Pawnee math teacher, for learning target, I can determine if two ratios are proportional. So we're moving to that word proportional and proportions in our next two learning targets. This one is just figuring out what does that definition mean of proportional? What's that concept mean? Remember expectations. Remember to pause, pause, pause. If you can't hear me, then go to a different location so you can focus better. Or remember to bring your earbuds next day in class so you can watch it or go home and watch it. You can always watch this ahead of time if you need to. That's what the point is. That way it's flexible for who needs it. Okay. And where's my thingamajiggy? There it is. Okay. So, table of contents. This is our first page. Again, we have proportional up here, and this is page 5. So you're adding to your table of contents. It's going to get some length to it. I'm going to flip to my next blank page, which I've already labeled ahead of time to save me time. So pause the video and write down your learning target and title it and put your page number. All right, so this one doesn't really have a definition so much as a sentence. They uses it all together. So, ending with the star. Okay, so I'm going to edit some of this part out. So back to clearly saying it. Make sure you've titled it, numbered it, written the learning target, and here's our first definition. It's more of a sentence that just uses all the words together. So two ratios that are equivalent, that's a Q, form a proportional relationship. So an example is 6/4 and 8/12. So these are two ratios written as fractions. This is an and sign in between. And my question to you is, are they proportional? Do they form a proportion? Meaning, if they are proportional, they must be equivalent fractions or equivalent ratios. So, how do I prove that they're equivalent? I simplify them as far as I can and see if they equal the same thing. So, 6 and 4, they're both even, so I can divide by 2. Divide by 2. I'm going to end up with 3/2, and that's as far as I can go, okay? So that's this equivalent ratio. I have a paper cut or something on my finger. Okay, 8 and 12, they're also both even, so I'm going to divide by 2. I'll end up with 4/6. Well, this is still, I can still divide by 2, so dividing by 2 again, and I get 2/3. Now, I'm going to be comparing. Is 3/2 the same as 2/3? No, these are not equivalent ratios, so they are not proportional. Put that big NO on there. That way you see this example first and foremost when you flip to this page. They are not proportional because they are not equivalent. Repeat after me. You can say it out loud or in your brain. They are not proportional because they are not equivalent. They are not proportional because they are not equivalent. So we're going to do a bunch of examples, okay? And this is where simplifying fractions comes in. Is 1/2 the same as 5/10? Are they equal? I don't know. So I'm going to put a question mark above the equal sign. That tells me as a reader that I don't know that they're equal, okay? So I want you to simplify, are these equal? Pause the video. Yes. These are equivalent ratios. 1/2 is the same as 5/10. They look different, but they both represent the same amount of pizza. If I have one pizza and I cut it into 2 pieces and I only have half of it, great. If I have a pizza and I cut into 10 pieces and I have 5 of them, it's the same amount of pizza that I'm eating, even if I can say I only had 1 slice when it's half the pizza. Or versus I can say I had 5 slices. All right, second one. Pause the video and try this one. 4/6, is that equivalent or is that proportional with 18/24? And third one in this row will be 10/3. Is it proportional with 5/6? So take your time, pause the video. Okay, coming back. 6 times 4 gets you 24. And 4 times 4 does not give you 18. So you could simplify fractions. Actually, I'm going to use my pen and write that. So 5/10 divided by 2 and 10 divided by 2, or not 2, 5, divide by 5, divide by 5 equals 1/2. So this is done by simplifying, okay? This one is done by patterns. I can multiply by 4, and if I multiply by 4 here, kind of like our ratio tables, by multiplying each number in the ratio by the same number, that was our definition of a ratio table. 6 times 4 is 24, but is 4 times 4 18? No, it's 16. Okay, so you can look for patterns. Patterns help you. Patterns in multiplying or dividing, but I'll just put multiplying so you have less to write. Patterns and multiplying. And then number 3, we can divide. Here's the division one. 10 divided by 2 gets you 5. Is 3 divided by 2 6? No. So, or dividing. So we'll extend that over to 3 because 3 had division in it. All right, so knowing that, the next 4 I want you to figure out. So again, we have 4 left. So on the bottom of our page, we're going to divvy this into 4 sections. So the first one, when you make birdhouses, so we have, well, I'm going to write this out horizontally. Okay, so you're building birdhouses, which typically is with wood and nails. So there are nails that you are using in the birdhouses. So when I make one birdhouse, it took 12 nails. When I did 2 birdhouses, it took 24. If I did 4 birdhouses, it took 48. And when I built 6 birdhouses, it took 72 nails. Is this proportional? Pause the video, figure it out. On 5, our next example, we're going to have a column. Actually, I'll do rows. So we can see rows. X. So I'm going to have a half for X, 3 for Y, 1 for X. I'll draw columns. 1 for X, 6 for Y, 3 halves to 9, and 2 to 12. Is this proportional? All right, pause the video. I'm going to do these first 2. So on these first 2, if I multiply by 2, can I multiply by 2? Is that true? Yeah, 12 times 2 is 24. Multiply by 4? Multiply by 4. Yes, that's true. Multiply by 6. Multiply by 6. Yes, that's true. So this one is yes. They form a proportion or they are proportional. Okay, this one, 3 times 2 gets you 6. 1/2 times 2 is 1. 3 times 3 is 9. 1/2 times 3 is then 3 halves. 3 times 4 and 1/4 times 4, yes. Okay, so this is a yes. I wasn't sure. I didn't know until we checked it. Okay, so that one's a yes. 2 left. Okay, so these are word problems. I'm going to write down the bare minimum, so you can write down even less than that if you just want to do the work. Up to you. So you can buy 4 boxes of Nike golf balls. So of golf balls for $30. But a friend buys 9 boxes of golf balls for $67.50. Are they proportional? Okay, that's your question. Are they proportional? So I'm going to pause it, write down your 2 rates or your 2 ratios and see if they're equivalent. The last one, so you swim your first 4 laps in 2 4/10 minutes. Then you do all 16 laps in 12 minutes. Are these proportional? Okay, So doing the math. So for golf balls, I have 4 boxes for $30. Because we just came off of Better Buy 2 learning targets ago, I'm going to put the 30 in the numerator because it's money and put the 4 below it so we can see that Better Buy if we wanted to think about it that way. And I'll put the 67.50 in the numerator and put 9 in the denominator. Now, we could find the unit rates for both of these, and that would totally be considered simplifying them and then figure out which one's the better buy. If there is a better buy, then obviously they're not equivalent. If there isn't a better buy, then they're the exact same fraction. But because this is dealing with money, I am going to use my calculator. So with this calculator, I'm going to be doing, you can do 2 ways. We could do the 30 divided by 4 and 67.50 divided by 9. If those are the same decimal, then we know we're equivalent and we're golden. Or we can try 9 divided by 4. So I'll do 9 divided by 4. Let's do that. 9 divided by 4 equals 2 and 2.5. So that means if I multiply by 2 1/4, 4 times 2 1/4 gets you 9. Is that also true with the 30? Let's see. So if I type 30 times 2 1/4 equals 67.50. Hey, they are proportional. Yes. Woohoo. Okay, so you both got the same deal. No one had a better buy. Okay, so the next one, good, you're going away. Awesome. So this next one, I'll push you up. First 4 laps. So I'm going to have laps and I'm going to have minutes. So in this case, I want to use a table because it has more units with it. You could put the dollars on here if you wanted to though. Okay, so laps. I have 4 laps are done in 2 4/10 minutes. So we want to see, did you just have a burst of speed or were you super slow because you're warming up in the beginning? Because you did all 16 in 12 minutes. So if you're proportional, that meant you're going at the same rate every minute. So you're going at a steady, constant pace, which is awesome for competitions because it means you can hold your own versus you're tiring out or you know you have a slow start. So then you know how to work on that slow start. This helps you as an athlete. So I need to know 4 times 4 gets me to 16. So is 2.4 times 4 equal to 12? Because this is not money and it's simpler numbers, I'm going to actually have you do it on the side. So 2.4 multiplied by 4. To do this, ignore the decimal. We'll think about it at the end. First, 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Plus 1 is 9. And then there's 1 number behind the decimal point. So I'm going to move my decimal 1 position. So if I was at a constant rate, I should have finished all my laps in 9 6/10 minutes. So this tells me the first 4 were actually super speedy and the rest of them were not speedy. So I definitely slowed down doing all 16 laps. So they are not proportional. That's interesting. There were only 3 things that were, or 4 things. I guess it was probably half. Half were proportional and half were not. All right, so that concludes our notes. Again, remember reflection after the video. Were you focusing? Were you productive? And did you learn it? Did this make sense? If it didn't, go ask your teacher your questions. Ask a peer questions. What stumped you? Let's figure out how you can learn best. All right? So have a great day. Bye.